Good morning, folks. Today, I, Joseph John Cervera, and my partner, Arpan Gupta, will be giving you a brief introduction on the topic, the technical architecture and the design of GitHub. So, our first question, what is GitHub? What you have to think of GitHub is it's a code hosting platform for collaboration and web-based version control platform for software developers. It means that it's a place where a lot of programmers working on the same project can host their codes together and simultaneously and work on it. It was founded on Git, an open source code management system used to make software builds faster. It was created by Linus Torvalds, who was also the founder of Linux. Now, the rest of the slide is a brief introduction on the history of GitHub.
Okay, so a version control system is a system that records changes to a file or a set of files so that we can recall the specific versions later. Changes in version control systems are usually identified by a number or a letter code, which is termed as the revision number. So we save these changes as commits, where each commit is a snapshot of the document at that point, and each revision is associated with a timestamp of the commit and the person who is making the commit. So basically, we can imagine version control as an RPG game where we save our game at every decision we make, so that we can come back to it later in case we face any issues. So the main power of GitHub lies in the fact that revisions can be compared, restored, and with some types of files they can be merged. This allows the maintainer to revert to a previous session, which helps in tracking others' edits, correcting mistakes, and defending against vandalism and spamming.
The next question is, what is Git? GitLab and GitHub use Git, which is a free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. Git stores the source code and helps to track all the changes made by the multiple developers. Thus, we can manage all kinds of possible conflicting changes made to the code. Also, Git is a popular method to implement software configuration management, which is the task of tracking and controlling changes made to the software. It is done through revision control, which is if something goes wrong, SCM can see what was changed and who changed it. Now comes the main part. How does Git work? A unique feature of Git compared to all the other SCMs is its branching model. Git allows and encourages you to have multiple local branches that can be entirely independent of each other. Consider a project of a game. There is one branch which takes care of its environment, one branch which takes care of the character design, one part which takes care of the other functions of the game. So, this is how a branching model works. A branching model now includes frictionless context switching, role-based code lines, and feature-based workload disposable experimentation. Another advantage of Git is that it's very fast, and nearly all operations are performed locally, at a huge speed advantage on centralized systems that constantly communicate with a server somewhere.
The most common design choices for storing data in version control systems include two methods. First is a delta-based change set, or a directed acyclic graph with content representation. First, a delta-based change set is one which encapsulates the differences between two versions of the content. However, Git uses a directed acyclic graph representation. Here, different types of objects are represented in this directed acyclic graph, which forms a hierarchy which mirrors the contents file system tree as a snapshot of the commit. And this snapshot reuses the unchanged objects wherever and whenever possible. So how does Git keep track of the commit and merge histories? Git uses a DAG to store the history. Each commit contains data about its ancestors, which can be 0 or many in number depending upon its occurrence in the tree. So this is a list of the .git files which are present in a directory which is cloned from GitHub. One of the important ones is head, which points to the branch where we have currently checked out of.
Here we have the visual representation of the hierarchical tree of the Git commits. At first we have the parent root, which is tree. Then we have the following commits. As you can see, there's an alphanumeric code a reference to each of the commits. This is how Git stores or references each of the commits by this alphanumeric string, which is unique to each of the commits. Let's take a look at the business model of GitHub. GitHub is delivered through software as a service or SaaS business model. SaaS business model is part of the three types of services, which is software as a service or SaaS, infrastructure as a service or ES, and platform as a service or PaaS. At the base level is ES, which hosts the infrastructure components traditionally present in comprises of the data center, including servers, storage, and networking hardware, as well as virtualization layer. After ES comes PaaS. PaaS provides hardware as well as software tools, usually those needed for application development to users over the internet. SaaS includes both of these, as well as it provides host applications and makes them available to customers over the internet. GitHub uses SaaS. Here's the visual representation of these three layers. At the base level is ES, which has the hardware, servers, storage, networking, firewalls or security, and the data center. The second level is PaaS, with the software, which is operating systems, development tools, database management, and business analytics. At the topmost is SaaS, which has all of these, as well as hosted applications or apps.
Okay, let's get introduced to a few terms we'll come across in the next slide. First, Git daemon. A Git daemon is nothing but a really simple TCP daemon which normally listens on the port, default Git port. It waits for a connection and asks for a service and provides the service when it's enabled. Secure Shell or SSH is a cryptographic network protocol used for operating network services securely over a network. Applications for SSH include remote command login and remote command execution. Load balancer. A load balancer is a device that distributes network or application traffic across a number of servers. Load balancers are used to increase capacity and reliability of applications. First, the Git client initiates an SSH session. The connection comes down off the internet and hits our load balancer. From there, the connection is sent to one of the frontends where an SSHD accepts. Now we have patched our SSHD daemon to perform public key lookups from our MySQL database. While performing public clones or pulls via Git, instead of using SSH for authentication and encryption, it relies on the server-side Git daemon, which accepts connections, verifies commands, and spawns a worker, which becomes the command process. GitHub, along with its primary web applications and hosting systems, runs a variety of subsystems which include job queuing, billing, SVM importer, etc., and side systems such as GitHub Pages, Gist, and a bunch of internal tools.
And thus, we come to the end of this session. I hope you enjoyed, and I hope you understood the brief introduction on GitHub. Sayonara, that's it folks.